Kevin. Thank you guys for tuning in. In this video, I'm going to walk you through how to solve a derivatives math problem. So yeah, it's going to be a lot of fun. And first things first, in this question, it's asking us to consider the curve given by the equation below. So here we have x times y squared minus x to the third times y equals 6. And with this equation that they've just given us, it wants us to show that dy over dx, which is sometimes known as y prime to some of you guys listening, we need to show that that equals 3x squared times y minus y squared over 2xy minus x to the third. So how are we going to do this? Well, first things first, we have to look at that equation that they gave us originally, and I'll pull it up right here. And that is x. So this is the equation that we had before. So that's x times y squared minus x to the third y equals 6. So with this equation that was just given to us, we need to take the derivative. In any case where we're looking for dy over dx, we're going to have to. It's going to involve derivatives, you know. So here, that's what we're going to do. So since x and y squared are held together by multiplication, as well as x to the third and y are held together by multiplication as well, we're going to have to be using the product rule. So the product rule states that I have to take, in this first case, that I have to take the derivative of x and I have to multiply it by y squared, and then I have to add that to x times the derivative of y squared, which is 2y times dy over dx. So I'm going to have to do the same thing over here with the x to the third times y. So here I've taken the derivative of x to the third, which is just going to give me 3x to the second, and then I'm going to multiply that by y, which I've done there. And then the next thing I'm going to do is I'm going to take the derivative of y, which is really just dy over dx, and I'm going to multiply that by x to the third. So that's really not too bad, just using the product rule there. And then when it comes time to taking the derivative of 6 is just like any other constant. When we take the derivative of a number just by itself or a constant, we're just going to get 0 as our derivative. So very easy from that standpoint. So next thing we're going to do, this is definitely one of my favorite parts of the thing, because it's just so easy to do. But all we're going to do is we're just going to get our dy's and d over dx's to the left side. We're just rearranging the question here, the equation, and we're just going to get all that other stuff to the right hand side. So our 3x squared y minus y squared, we're going to get that to the right hand side. And now we're just going to primarily look at the left hand side next. So what I've done there, what you just saw was I took out the dy over dx. So basically all I did was I factored that out of the equation on the left hand side. I'll go back just so you guys can see that, right? Because it was in the factors of both of those, and now that's made the equation a lot easier for me. So now to get dy over dx by itself, all I have to do is divide the left-hand side by 2xy minus x to the third, as well as the right-hand side by 2xy minus x to the third. So yeah, look at that. That's just going to give us the equation that it was looking for, or I'm sorry, the value of d over y over d over x. So perfect. So that's exactly what it was looking for. Remember, we just had to take the derivative and then solve from there. So that's perfect. Now, part B. It's asking us to find all the points on the curve whose x-coordinate is 1 and write an equation for the tangent line at each of these points. So let me just look at that again. It's asking us to find the points on the curve whose x-coordinate is 1. All right, so thinking about that, I know I still have to be using my original equation, right? That's very important. So knowing that now that I have to find where on the curve it's 1, the x-coordinate is 1, all I'm going to do is I'm going to plug in 1 for x every time that I see an x in my equation, right? So here we go. That's really not that bad. So that's just going to give me 1 times y squared minus 1 cubed times y equals 6. So here we have it written out again, just so you can see it, nice clear image. But yeah, so now we have to find the values of y in that parabola. So really, all we're gonna have to do now is factor the equation. So with that equation, we're gonna get y minus 3 times y plus 2, and that's all gonna equal 0. So I hope you guys all followed that. We're just using factoring, and that's obviously people have used that for a long time. Hopefully that could come easy to you, and you should see that equation was an easy to factor equation. So now all we're going to do is we're going to set y minus 3 equal to 0, as well as y plus 2 equal to 0, and that should give us solutions of y equals 3 and y equals negative 2. So right now we're going to look at our derivatives equation. Right, so I've got that right here, and all we're going to do is plug in our values that we just received for y and x, and we're just going to plug those back into the derivative equation to give us the slope of the line that we're looking for, which is the tangent line. So here you see that I have everywhere that you see an x, I put a 1, and everywhere where you see a 3, I've put in. I'm sorry, everywhere where you see a 3, that used to be the y value. So really, it's just plugging in what we already know. So here, all I've done is I've just simplified the equation. That makes it a lot easier to look at, and really, we get an answer that doesn't seem too bad. So we get 9 minus 9 over 5, and this is just going to give us 0 over 5, and that's just going to simplify to 0. So we know that the slope of that tangent line is going to be 0. So here are our knowns, y equals 3, and the slope we now found out is 0. So all we're going to do is we're going to plug that into the point slope form, which is y minus y equals m, which is slope times x minus x. So here I've done that, and we have y minus 3 equals 0 times x minus 1. So now what we're going to do is we're just going to distribute the 0 to the x and to the 1, and that's just going to give us a value of 0 for both. And now we're just going to be left with y minus 3 equals 0, and all we got to do is just bring that 3 over to the other side to give us y equals 3. I kind of like that animation there. All right, so now we've got to do the exact same thing for this right here. So now that we found out before that that line equals y equals 3, so now we'll find out what this tangent line equals. So right here we found out that the value of that previous y, which we had to factor for, equals negative 2. So once again, we're going to plug the 1 and the negative 2 into this derivatives equation to find the slope of the tangent line that we're looking for. So here, every time that I see an x, I'm just going to plug in a 1, and every time I see a y, I'm just going to plug in a negative 2. Pretty straightforward, not too bad. So here I've just simplified the equation all the way down to negative 10 over negative 5, which is just going to give us a positive 2 as our slope for this tangent line. So let's take a look at the knowns that we have. We have y equals negative 2, and slope equals 2, equals positive 2. So now, just like we did with the other tangent line, we're gonna have to plug our knowns into the point slope form. So here we have y plus 2 equals 2 times x minus 1. So really, when we simplify this, we're gonna get the tangent line of y equals 2x minus 4. So remember, the other tangent line was y equals 3, and this one is y equals 2x minus 4. All right, so here is the third and final piece of this problem that I'm walking you guys through, and it's asking us to find the x-coordinate of each point on the curve where the tangent line is vertical. All right, so once again, we're just gonna have to take a look at our dy over dx equation. So in this case, we have to, since we know that the line is vertical, we know that there is no change in slope. So in that case, we can set dy over dx, the dx, so the denominator, equal to 0. So here I have dxy minus x to the third equals 0. Once again, because there's no change, I can assume that it's 0. Right, so now that we have x times 2y minus x squared equaling 0, the next step that we're going to do is set both of our factors equal to 0. So I'm going to start off first by setting x equal to 0. And then this is going to give me a solution of x equals 0. And now, after that, we must solve for y. So once again, I'm going to set 2y minus x squared equal to 0. Here you are. This is what I've done. So now, once I carry over the x squared to the right-hand side, we're going to be left with 2y equals x squared. And now we know that y equals 1/2 x squared. So now it's time to evaluate the equation, our original equation, which I hope you guys all remember. So if x equals 0, all we're going to have to do is now whenever we see an x, we're just going to plug in our value of 0 that we just derived for. So now that everything is being multiplied by 0, we get that 0 equals 6. And I hope that you guys all know that that's not possible. I mean, in no way does that make any sense. So this means that this is not a real answer. It's extraneous. Therefore, it can't be an answer to this question. But now we're also given that y equals 1/2 x squared. So we're going to do the same thing. We're going to plug the value of y in for wherever we see y is in our original equation. We're just going to solve. So here, I've done that right here. Where we see y squared, I've put in 1/2 x squared. And when we see y over here with the x times x to the third, I've just put in 1/2 x squared. So now all I'm going to do next is I'm just going to add together our exponents. Hopefully you guys have practiced that in school, and it comes a little bit easier to you. So this 2 and this 2 right here are going to add together. So we're going to get x to the fourth, and this 3 and this 2 are going to come together, and we're going to get x to the fifth. So as you can see, that's exactly what happened here. So that looks pretty good. But now, what I'm going to do next is I'm just going to multiply that x, as you see right here, this x, back in with the x to the fourths. And this, as you can see, will give us x to the fifths throughout the equation. So this is just going to make it easier to look at, easier to solve for an x when they're all the same and consistent. But I'm still not liking these fractions hanging out right in front of the x's. So what I'm going to actually do is I'm going to try to eliminate them by multiplying by 4. And what this will do is this will give me, instead of 1/4 x to the fifth, it'll give me 1 x to the fifth. And instead of 1/2 x to the fifth, it's going to give me 2x to the fifth. And that's also going to change the value of our 6 because it's being multiplied by 4. And that's going to give us 24 instead of 6. So what that all boils down to is x to the fifth minus 2x to the fifth equals 24. So all we're going to do is we're going to subtract the negative 2x to the fifth from the x to the fifth to give us negative x to the fifth equals 24. So now we're just going to want to take, we obviously want to get x all by itself. So we're going to have to take the fifth root of positive x and the fifth root of 24 to give us x equals negative 24 fifth root. So guys, thank you so much for tuning in. I hope you guys all learned something, and I hope you guys come back again next time for another video. So have a nice day. Adios.